The definition of a Cauchy-Euler equation is this ordinary differential equation. It's linear, but its coefficients are a certain way, so you can have a sub n, that's going to be some number. We have x to the nth power, and then times the nth derivative of y, plus some new coefficient here, some number, a sub n minus 1, times x to the n minus 1, times y to the n minus 1th derivative, plus dot dot dot, all the ones in between, plus here we go to a subscript 1 times x to the 1 power times the first derivative of y, plus here it's x to the 0, so that's why I don't have the x there, but it's a subscript 0 times y, 0th derivative, equals 0. And it's not that much more complicated than a constant coefficient equation, right? It's got a very strict format here of having the same power of x on every derivative of y, the same order of the derivative, but it was hard enough to solve and interesting enough that it actually got named after some mathematicians. Their name is attached to it. So a few things about it. The homogeneous solutions can be found by guessing y equals x to the r, where we don't know what r is, and solving for r to satisfy the ODE. This is similar to solving for the constant coefficient case where we would guess e to the rx. And this guess really only works if the powers on the x's work the way they are, where every single power of x is going to be the same as the derivative of y it's attached to. This x to the r guess will work. And the solutions are sometimes restricted to x greater than 0. The reason for that is, let's say r is equal to 1/2. Then we are going to have x to the 1/2 power. It's one of the homogeneous solutions, which means x to the 1/2 is the same thing as the square root of x, and the square root of x is not defined for negative values of x. Right? So depending on the values of r, you can't always have x positive and negative, or even 0 sometimes. You can get around it by using the absolute value of x to the r. That actually works for x positive and negative, but not always x equals 0. So this is strictly positive, this is strictly negative, so that leaves out 0. And the reason x equals 0 doesn't always work is, what if you end up with a solution where r is equal to -1? Then one of the homogeneous solutions is x to the -1. Well, that's the same thing as 1 over x, and 1 over x is not defined for x equals 0. So that's the basic description. We'll go through some examples and other ways to solve this equation, and hopefully you get some intuition on how to use what this is and how to solve your homework problems.